Hello everyone! So the question we have here is, to determine whether these points, P, Q, and R, are collinear, form a right triangle, or neither. And we're given a hint even to use vectors. Okay, well, if we let, let's say, a vector equal the distance from P to Q. So let's say a vector equals PQ vector. Okay, well, what does that equal? It just equals the distance from P to Q. So we can just subtract off our Q component from our P component. So just do 2 minus 1 gives us 1. 1 minus a minus 2, so 1 plus 2 gives us 3. And then minus 2 minus 0 gives us minus 2. We use these little pointy brackets here to say now we have a vector. Okay, so this A vector was from P to Q. How about we let B vector be from P to R? So B vector, let's say we let that be PR vector, which equals what? Well, I think it's 5, 1, minus 3, right? Just take our R minus our P. So 6 minus 1, minus a minus 2, and then minus 3 minus 0. Gives us our B vector. And how about we let C vector equal what? Well, if A was from P to Q, B was from P to R, how about we let C be from Q to R? So we let C vector equal Q R vector. And what does that equal? I think that's going to be 4 minus 2 minus 1. Okay. So now we have these three vectors. And now the first question was, are these points collinear? Well, what does that mean? Collinear just means the points are all on the same line. They lie on the same line if they're collinear. So let's say we have some line and we have these points, P, Q, and R. So here we have P, Q, and R. Now these points are in 3D space, right? These are all X, Y, and Z coordinates. But I can't draw in 3D, so you can just think of this line as, you know, if this line was like standing up, coming up here in 3-dimensional space, you could have, you know, P, Q, and R. So that's basically the same line, but now it's just lying flat here. So if these points all lie in the same line, what has to happen? Well, we have these vectors, right? We have a vector from P to Q. So there's our A vector. And then we have the PR, so this long vector here. And then we have QR, right? Well, notice, I mean, if the points all lie on the same line, then the vectors have to point in the same direction. So that means they're just scalar multiples of each other. Right? If the points lie on the same line, then the vectors between those points have to go in the same direction. They're just a scalar multiple. What does a scalar multiple mean? It means just take a number, a scalar, times that vector. And it just either makes the vector bigger or smaller. It just scales the vector. That's what a scalar does. So are these vectors scalar multiples of each other? Well, we can check any two vectors. We can check A and B. And you look at your x component. Well, how do you get from 1 to 5? Well, you multiply by 5. So if it's a scalar multiple, then you have to multiply every component by the same scalar, by 5. Or to get from 3 to 1, you definitely don't multiply by 5. So therefore, they're not scalar multiples of each other. And you can check the same for any other of these two vectors. You can check A and C. You know, to go from 1 to 4, you must multiply by 4. But that is not how you go from 3 to negative 2. So none of these vectors are scalar multiples of each other. Therefore, these points do not lie on the same line, and they are not collinear. Okay? So we found that these points are not collinear. Now the next question was, well, do they form a right triangle? Well, how would you figure that out? Well, if we think about this for a second, if we had a right triangle, so if the points form a right triangle, then we have 3 points. Now they're in 3 dimensions. This right triangle is it's in 3D, right? But we can now think of it in 2D here. And if we had our 3 points, well, what has to happen if they form a right triangle? Then 2 of the vectors would have to form a right angle, a 90-degree angle. And they'd have to be perpendicular to each other. Okay? So, well, how can we tell if the vectors are perpendicular to each other? Well, if you are aware or not, but if you take the dot product of 2 vectors, and if the dot product equals 0, then that means the vectors are perpendicular. So if we just dot these vectors, let's say if we dot A dot B, well, what does that equal? A vector dot with B vector. Well, a dot product is pretty simple. All we do is take the components of A and B, and we multiply them and add them up. So we take 1 times 5, that's 5, plus 3 times 1, so 3, and then plus negative 2 times negative 3, so plus 6. Well, that equals 14. So that's not 0. So does that mean the vectors, does that mean that these points don't form a right triangle? Well, not necessarily, because just because 2 vectors don't form a right angle doesn't mean that 2 could, right? We only need 1 right angle to have a right triangle. So we need to check all the possibilities and see if we have anything that forms a right triangle, that if the dot product is 0 for any of the 2 vectors. And if not, then we can say neither. But we haven't checked all of them yet. So let's check. We did A dot B. How about we do B dot C? So B vector dot C vector. What would that equal? Well, that would be 5 times 4, so 20, plus 1 times negative 2, so plus a negative 2, and then plus negative 3 times negative 1, so plus 3. Well, that equals 21, I think. So that's not 0. All right, we could check one more here. Let's do, how about we do A vector? We did A dot B, we did B dot C. How about we do A dot C? What do we get here? A dot C. So we get 1 times 4, which is 4, plus 3 times negative 2. So plus a negative 6. And then plus negative 2 times negative 1. So plus 2. And what does that equal? That's 4 minus 6. That's minus 2 plus 2. Oh, that equals 0. So the dot product of A vector dotted with C vector equals 0. That means that those two vectors, right, are perpendicular to each other. So right now, I'm not sure what points these are. If this is, this could be P, Q, and R. This could be P, Q, and R, but 2 of the vectors are perpendicular. That means they form a right angle, right? They hit at a 90-degree angle. So therefore, yes, these points form a right triangle. And that was pretty simple. I mean, I think, this is from a Calculus 3 class, actually. But I think once you really understand what's going on, it becomes really simple. All right, I'll see you guys later.